This last example for section 5.6, we're going to estimate that definite integral, but we're going to do different methods to do it. So we have the 4 subintervals, but we're going to do it with the right sum, a left, a midpoint, and a trapezoidal. All right, so going from 0 to 40. So here's the data in the table. We don't know what f is. We just have to go off of the numeric values. So let's start with the right Riemann sum. So what shape do we use with a right Riemann sum? Well, that was going back to 5.3. So the shape we used were rectangles. So base times height. Well, the thing about these is we're doing 4 subintervals from 0 to 40. So each base is 10. So if I know that every single base is going to be 10, I'm just going to factor that right out to the front. And then I just have to add up the heights. So you have to decide now which thing you're going to be using for its height. So the first interval, you're going from 0 to 10, and it's a right Riemann sum. So you kind of have to think of it on like a graph. So from 0 to 10, so when x is 0, y is 4. When x is 10, y is 6. So if you look at these two values, the 0 and the 10, which one is on the right? That would have to be the 10. This is the left, this is the right, so this is the right. So what y value goes with the 10? The 6. So that's the height we're going to choose. So you're going to choose the right side of every single interval. So the 6 goes with the 10. The next interval from 10 to 20, 20 is on the right, and its height is 0. 20 to 30, 30 is on the right, and its height is 2. 30 to 40, 40 is on the right, and its height is 8. So add those up, multiply by 10, and you get a 160. Okay, so the left Riemann sum, you're still using rectangles, and again, the base is still 10, so I'm just going to factor that common base out, and then it can just add up all the heights. Well, now it's flipped. Now you want the height that's on the left. So from 0 to 10, 0 and 10, which one's on the left? The 0. What y value went with 0? The 4. And then just keep doing that all the way down. From 10 to 20, 10 is on the left, so you go with the 6. 20 to 30, 20 is on the left, so you go with the 0. 30 to 40, 30 is on the left, so you go with the 2. Add those up, multiply by 10, and you get 120. So in this case, the 160 was your upper, and the 120 was your lower sum. Okay, now let's do a midpoint. So again, it's still rectangles, each base is 10. But now instead of choosing the height that goes with 0 and 10, I want the one that's in the middle. So now I want the height that goes with the 5. So between 0 and 10, the middle is 5. So use the 1. Next one would be 15, and its height would be 9. Next, the 25, its height is 3. And then the last, the 35, and its height is 7. And you get 200. Okay, now for D, do a trapezoidal Riemann sum. So I'm not going to factor anything out just in case it was confusing on the last one. So let's just do the formula just straight out. So it's 1/2 times the height. So that would go from 0 to 10. The height is 10. And then the sum of the bases. So adding up the 4 and the 6. Okay, trapezoid number 2. From 10 to 20, the height is 10. And you're adding up 6 and 0. (20 to 30, the height is 10 again. And then the heights would be 0 and 2. Or sorry, the bases. 30 to 40, the height is 10. One more time. And then the bases would be 2 and 8. So if you do all the arithmetic in there, you end up with 140. All right, so we have, that's one definite integral being approximated 4 different ways with a table of values. Okay, so go ahead and try the homework and let me know if you have any questions either by email or just talk to me during office hours.